Okay, 12.4 review. These were inscribed angles. Remember, inscribed angles were inside the circle. So right here, we see angle ABC is directly related to the arc that it intercepts, right? That relation tells us that the angle is half the measure of the arc. So if the arc is 60, the angle's got to be 30. If the angle's 30, the arc's got to be 60. Basic. We talked about these two situations where we have two different inscribed angles. ABC intersects arc AC, and oh my goodness, ADC intersects AC. All right, so that's what this says. If inscribed angles of the circle intercept the same arc, then the angles are congruent. That's what this means. If they intercept the same arc, then the angles have to be congruent. It's kind of common sensey. We had the situation when that inscribed angle subtends a semicircle. That means it creates a semicircle. It forms a semicircle. It cuts it into a semicircle. If and only if the angle is a right angle. Remember, if and only if means it goes backwards. So if you know the angle's a right angle, it's got to subtend a semicircle. If it subtends a semicircle, it's got to be a right angle. And then we talked about the inscribed angle theorem, which basically just said opposite angles of a quadrilateral are supplementary, right? So A and C have to add up to 180 degrees, and B and D have to add up to 180 degrees. We had an example and algebraic situations. These have to add up to 180. Combine, divide, fill it back in. Pretty basic stuff. Be safe.